Okay, before we jump into stairs in Revit, there's some basic terminology and some basic kind of principles that I think are important to cover and to understand before we actually start using the stair command. The first thing in kind of understanding how to create stairs is understanding how big to make them, right? Specifically, the riser and the tread. Okay, so we're all on the same page. That right there is known as the riser. And that part where you put your foot on is the tread. I apologize for the wonky looking staircase, but you get the point, right? So we have the riser and we have the tread, which we also kind of call the rise and the run, which refers more to kind of determining slopes and angles, okay? When it comes to the riser and the treads, we follow a basic rule called the 7-11. Okay. What the 7-11 means is that your risers have to be no higher than 7 inches. So that's a 7-inch maximum. Okay. So this point right here, that has to be 7 inches max. It cannot go up higher than 7 inches. Your tread has to be 11 inches minimum. Okay. So I know that begins to get a little confusing, 7 inches max, 11 inches minimum. Just kind of think this through. You don't want a step that is really tall, right? That becomes really difficult to walk up. So the riser, the height is 7 inches, no more is the max at 7 inches. The tread, on the other hand, that's where you put your foot on. So you don't want that to be any smaller than 11 inches because then your foot's not going to fit on it. Okay. So this kind of property, the 7-11, is the golden kind of rule when it comes to creating steps. Okay. So when we create stairs, we generally try to get this as close to possible or as close to 7 inches max, 11 inches minimum as possible. The tread, there's a little kind of flexibility there because we could go ahead and do 12-inch treads or 14, 15-inch treads. What I find really interesting is we all kind of recognize whenever there's something off with staircases, right? If the riser, have you ever had to go up those steps that are like 3 inches? And it's really awkward and it's really uncomfortable. It makes you really notice that these stairs are very difficult to kind of walk up. Or vice versa, when the tread is, let's say, 18 or 20 inches. And so it's not wide enough for your second step. So you kind of have to do 2 steps per staircase or per tread. And that makes it really awkward and uncomfortable too. So for that reason, we try to stick to the 7-11 rule as much as we can. However, because of building heights and because the amount of space that we have, all of those also begin to factor in what is the height of our staircase or our riser and what's the length of the treads. So all that plays a role in determining what our riser and our tread or what the rise and the run is of our staircase. Okay. So these are two important factors that we're going to have to consider. The other thing is our stringer. Okay. So there's a term called the stringer, and the stringer, if we were to continue this, is essentially the structure, the support. Okay. Depending on how you create your staircase, there's a good chance you're going to have, if it's a wood construction, you're going to have a wood stringer. And that's essentially going to be kind of like I don't know, maybe like a 2x12. And they will notch out the portion for the tread. I'm sorry, for the riser and the tread. So they actually cut that out. And then you go ahead and you lay your new piece of wood above that. okay? And that's how we create the stairs. But what you need to understand is that when we're referring to the stringer, we're essentially referring to the structure or the portion underneath the riser and the tread, okay? So that's the stringer. That's the structure aspect. Next, we have our balusters, okay? Now, now, hold on. Let me go back to the stringers. There's two ways. There's two general ways of creating the stringers. One, just like I was saying, we do the cutout underneath, or we do the cutout on the piece of wood, and we cut the piece of wood and we place the piece of, we put our treads above the stringers. The other one is we do kind of at an angle like that, and we actually show the piece of wood on the side here. So you could actually see the piece of wood or maybe the metal on the side. So sometimes the stringer goes below the staircase, sometimes, or the steps, sometimes the steps are attached to the actual stringer themselves, okay? So those are the two methods of stringers. Then we come to the balusters, okay? And now the balusters are placed on the stringer, okay? Well, there's two placements, sorry. It's placed on the stringer or it's placed on the tread, which is attached to the stringer. So the balusters, just so we're all, so you have an idea of what it is I'm talking about, are these guys that go on the side, okay? Now, typically, the balusters, and we have guardrail, something like that. So typically the balusters are, not typically, the code is no more than 4 inches apart, okay? So the spacing is such that these two cannot be anything any bigger than 4 inches. I'm sorry, that's not minimum, that's maximum. So 4-inch maximum. The reason for that is you don't want a little kid slipping through the staircase, slipping through the balusters and falling over to the other side, okay? So these balusters can be attached to the stringer the way I drew them right now, or they could also be attached to the tread, okay? Which should look something like that. Now we've seen both of them. I'm sure you've seen both types. What's interesting is that I often find that students pay much closer attention to staircases or to anything that we've covered so far, now that they have a better understanding. And staircases are really fun to kind of take a look at next time you're in a staircase, because there's so many variations on how a staircase can be constructed. It's interesting to kind of follow the different kind of approaches that and the decisions that were made to create that staircase. Okay, so 4 inches minimum. These are called the balusters. Okay. Next, we have the handrail and we have the guardrail. Now the handrail is not the same as the guardrail. I'm not sure if I'll be able to erase this. Let's see if I can. So the difference is that one is for the hand, right, to help kind of assist you as you walk up the staircase. The other one is to make sure you don't fall over. Okay, so the other one is to make sure that you don't actually tip over to the other side. So this is the handrail, and this is the guardrail. The handrail has a height of 36 inches from the tread. Let's go with the thicker. Okay. So remember, this is the tread. So 36 inches at all times from the tread. Okay. That's the comfortable height. It's actually 34 to 36, but I usually use 36. 34 to 36 inches. Okay. Again, the handrail is to kind of help guide you or just kind of give you some support as you're walking down the staircase. The guardrail, though, is different. The guardrail is 42 inches, okay, from the tread. And the guardrail, again, is to make sure that you don't accidentally tip over from the side of the staircase and you don't fall off. So the guardrail is going to help kind of protect you. Now it's 42 inches. Okay, let me write that over here somewhere. Maybe it's easier to see. Now the guardrail height, that's true for any guardrail. Okay. So we have we'll place guardrails not just on staircases, but say on balconies, right? So all of the guardrails are going to be 42 inches minimum. Okay. So I think that's it. So we've covered the rise and the tread, which is 7 and 11. Okay. We've covered the stringers, we've covered the balusters, and we've covered the handrail and the guardrail. Okay, so these are all kind of key terms that are probably going to come up as we begin to explore the different options in Revit when it comes to staircases.